No one has ever made such a gasifier. It works on boiler exhaust gases. Hot gases, which come out of industrial equipment, heat waste fuels, garbage or pine needles. Generator gas is produced which can be fed, for example, into the same boiler. Why am I interested in this unusual and one-of-a-kind gasifier? People often ask me if it is possible to turn exhaust gases into combustible gas. For example, several charcoal producers wanted to use the heat from the waste gas to heat the wood, so that it would also be converted into a useful gas. Or vice versa, to build a gasifier so that the gas, which comes out of it, heats the wood, which would be turned into useful charcoal for sale. This gasifier is something like this. It was created in Poland. The work started back in 2008. The work on which my video is based dates back to 2017. Scientists tested a gasifier in the lab and in an industrial power plant called Marcel Dust Combustion Plant, in Radlin, Poland, already on a large scale. It worked well. Let's analyze this rotary gasifier. A link to this work is in the description under the video. This gasifier consists of a rotating drum in which any fuel, biomass, garbage, straw, peat, sewer sludge, livestock waste, chicken manure, etc., can be converted into gas. It is very important that this rotary gasifier is insensitive to fuel humidity, particle size, and ash melting temperature. In fact, it is omnivorous. The gas obtained from waste fuels is fed back into the boiler. Low-quality fuels cannot be fed into industrial boilers because of their composition, which causes such problems as corrosion, ash melting, etc. Turning these fuels into pure gas and feeding industrial boilers with it is a great solution. Figures from this work were obtained from testing the device on softwood pellets. In this work, the authors used exhaust gases from the co-combustion of coal and coke oven gas. It is believed that gasification occurs at a temperature of 700 degrees. The gasifier we are talking about works at a low temperature of 350 to 550 degrees because the exhaust gases do not have such a high temperature. We know different types of gasifiers, downdraft, transverse, etc. This one does not belong to any of these types, it is something completely new. There are several variants of rotary gasifiers, but none of them run on exhaust gases. Fuel is fed into the reactor through the auger and water-sealed sector feeder. Exhaust gas enters the reactor. Combustible gas comes out of the reactor and is fed into the boiler. The laboratory unit was tested at 350 to 550 degrees Celsius. The table shows how the softwood pellets behaved, how the fuel lost mass, giving off gas, how much gas was obtained, and what was its composition. You can see an important indicator in the table. As I understand, the fuel gives off 63% of its mass in the form of gases. And you can see the time required for this. By the way, the authors of the gasifier tested other fuels, including rubber waste and sewer sludge, which lost 30% of their mass. The graphs in the study show this. Open the link and take a look. The rotary gasifier reactor consists of a rotating drum with adjustable rotation speed and a two-piece casing. It is rotated by the gear motor through the chain drive. The number 2 labels the fuel hopper, 3, the auger, 4, the sector or rotary feeder. From 0 to 200 kilograms of fuel is fed hourly. The exhaust gas is fed into the rotary gasifier through 400 by 200 mm chimneys. The rotary gasifier is sealed as a hopper in the hopper, and the gas comes out of it through a separate gas line. Exhaust gases come out through the flue duct 5. The gas comes out through duct 6, 8,600 cubic meters, gas mass 1,250 kilograms. Of exhaust gases from co-combustion of coal and coke oven gas passed through the gasifier reactor hourly. The gasifier was heated for 1 hour before feeding the fuel. This is shown in Figure 4. The authors conducted 4 experiments. The temperature of the gasifier rose steadily. When it reached 800 degrees, they stopped supplying the gasifier with fuel. The test results are shown in Table 3 and Figure 5. Then they waited until the device cooled to 500 degrees and resumed feeding 187 kilograms of fuel per hour. The amount of exhaust gases was reduced to 681 kilograms per hour in order not to overheat the reactor. After the laboratory tests, the authors started building an industrial prototype. Let's look at Figure 11. Exhaust gases 1 go to heat exchanger 9 and further to the chimney. There is a Rotary Gasifier 15 on their way. The gasifier is fed with crushed fuel through auger 13 and exhaust gas 10 flowing through the injector. The exhaust gases are taken from the combustion duct 8 by the flow of working medium, water steam, compressed exhaust gases, which is fed to outlet 12 through nozzle 10. These exhaust gases enter reactor 15 where biomass is thermally treated. The exhaust gas outlet injector 10 is adjusted according to the technological requirements by control valve 7. The valve is built into the auger channel 6 and the drive spigot 12. The exhaust gases leaving reactor 15 with combustible gas products of the decomposition process are fed to burners 3 and 4 while solid combustible and non-combustible products are transported through airlock 14. Exhaust gases are fed partially. In order to overcome the resistance, a saturated steam nozzle is used, figure 16. As far as I understood, the gasifier used oxygen from this industrial coal dust boiler. Its exhaust gases contained 18% oxygen and had a temperature of 400 degrees. The obtained generator gas had a calorific value of 1,500 kilocalories. After testing on wood pellets, the authors of the device are preparing for tests on other waste fuels. See you soon.